Hi, this is Professor Kim Nelson with the Jewelry Design Department of the Fashion Institute of Technology. Doing another tutorial here for Rhino. I'm going to go back to a very basic concept because I'm having some students who are having a tough time understanding construction planes. The thing you want to know about a construction plane is, well, first off, visually it's easiest to think of it as the grid. The grid is not the construction plane, it's the visual representation of a construction plane. The grid could go for infinity because mathematically speaking, the construction plane does go to infinity. It gives you a way of visualizing coordinates. Remember, in Rhino, everything is coordinates. It's a mathematical program. It's a calculator on steroids. So you want to be aware of the fact that to Rhino, everything is in X, Y, and Z space. You have global coordinates and you have local coordinates. Global coordinates are reflected directly by the top seaplane. Okay? That's not to say the top seaplane is superior to any other seaplane. It just reflects world or global coordinates. World coordinates, X runs right and left, Y runs up and down, north and south, and Z comes directly towards you. In global coordinates, that means, it's going to sound a little weird to say, but in global coordinates, that means that your X coordinates are running right to left. Okay? Negative direction is to the left. Positive direction is to the right. Okay? My grid's set at 10 millimeters or 10 units, so this would be 0, minus 10, minus 20, minus 30. 0, plus 10, plus 20, plus 30, plus 40. Okay? Y coordinates would be going in this view towards and away from us on the ground. But if you're looking straight down at the ground, it's up and down. Okay? So minus would be going downward or towards us. So that'd be minus 10, minus 20, minus 30. Plus 10, plus 20, plus 30 in the Y direction. Okay? Z is coming directly perpendicular from the seaplane, which in world coordinates means flying up and down into the air. And this is where we can really start to talk about a control plane. Seaplanes only give you the ability to go in two coordinate directions. Top gives you X and Y. Okay? You can't do Z from the top seaplane. It's not available to you. And this is an important thing to understand when you're thinking about seaplanes, is that from a practical perspective, a seaplane really tells you where your mouse can go, okay? Where you can work. I think a lot of people become confused, okay? Let's say I'm trying to draw a U shape, a hill, that goes up into the air. Well, in perspective viewport, that looks like a hill form, but in reality, it's flat. No matter what I try and draw, if I try and draw a face here in the air, okay, clearly that face is floating in the air. You can see that the construction plane is on the ground, face is floating in the air. We can all see this. It's clear as day unless you revolve the view. Remember, the grid is a visual representation. The seaplane itself goes to infinity. So what looked like a normal face floating in the air is actually drawn flat. And I think this is where a lot of people become confused. When you tell them that the C-plane is what your mouse is drawing on when you're working with curves in Rhino, or pick points. It's not just curves, pick points. If you're doing a scale operation, a scale transform, okay, your pick points will be on the C-plane. Okay, so if I come to here for my scale, that pick point is on the C-plane. Okay, so you're drawing on the C-plane. A lot of people think that that means that you can draw on the C-plane. You set up a C-plane so you can draw on it. That's a very positive way of thinking, but it's not exactly accurate. You can't draw anywhere else. Whatever C-plane is active is the only place your mouse can go. This is it. It's all you've got. Okay? I like to say that Rhino is not a 3D program. It's a 2D drawing program that lets you work in 3D. While that's not entirely true, it's a useful perspective to have. You are limited to your C-plane much of the time. So if I want to go in the Z direction, going back to our discussion about global coordinates, I can't use a top C-plane to do that. I would have to use, for example, a front C-plane. Okay, now if I lock my camera to a perpendicular relationship to this C-plane, if I lock it there, right now this is a perspective camera so I can revolve around, but if I lock it so it can only be perpendicular to the C-plane, then I would no longer have a perspective viewport, I would have a front viewport. Same, correct? And this Z direction in global coordinates works the same way. Up into the air is positive Z10, Z20, Z30. Dropping down below 0 would be minus Z10, Z minus 20, Z minus 30, and so on. Okay? Now, like I said, that's global coordinates. It gets a little confusing because local coordinates are based on the C-plane that's currently active. So right now, this is no longer considered Z-axis. Once I make in local coordinates, the beautiful thing about a top C-plane is that local coordinates and global coordinates are the same thing. World coordinates, like you can use world or global interchangeably. World coordinates and local coordinates are the same. Once I go into a different C-plane from top, that's no longer true. In local coordinates, this is now the X direction. This is now the Y direction. And coming towards me directly is the Z direction. Okay? So, in local coordinates, this is actually plus Y. Okay? So this is Y plus 10, Y plus 20, Y plus 30. Okay? But in global coordinates, that's Z plus 10, Z plus 20, Z plus 30, because the global coordinates reflect what you would see in the top C-plane. So, I wish the concepts were easier, more clear. I'm doing my best here. So your local coordinates are always going to be X and Y and Z, just like global. But a C-plane will only ever give you access to the local X and Y. Okay? So that's a front C-plane, X and Y. Right C-plane, X and Y. Top C-plane, X and Y. Okay? I don't like to think in local coordinates if I don't have to. I always tend to think in global coordinates. It makes it easier for me. There are times, especially in transforms, when Rhino is thinking in terms of local coordinates, but usually you don't have to worry about that. what you have to be aware of is that there are two coordinate systems, global and local. Global and local for the top seaplane are the same thing. So if you want to get a good visualization of what the coordinates are in the world coordinate system, have your top seaplane active. But all seaplanes, when you reactivate a different seaplane, that's going to go into a local coordinate system, or display, I should say, a local coordinate system of X and Y and X and Y. It is kind of useful to know how these all relate to each other in a global coordinate system. Okay. In world coordinates, this direction is Y, positive Y. In front seaplane, that's negative Z. Because positive Z would be coming towards you. In local right seaplane coordinates, that is positive X. And back to top seaplane, it's positive Y. Okay? So, for top seaplane, it's Y, which is always represented in green. Front seaplane, it's Z, which is blue. Right seaplane, it's X, which is red. Back to top seaplane, which is the global coordinates. Kind of think of them as the real coordinates. It's back to being green for the Y. Okay? So, you have global coordinates, local coordinates. Try your best to really keep your head in global coordinates. With this in mind, be aware that you are only allowed two directions of global coordinates on any seaplane, because seaplanes are flat. They are a virtual or a virtual surface. It's a surface that you don't see, a mathematical surface that expands into infinity. It's planar, which in Rhino means flat. Okay? So, in the top seaplane, thinking in global coordinates, we have access to X and Y. In the front seaplane, thinking in global coordinates, we have access to Z and X. Okay? See if I can turn off much better. Okay, so now I can draw lines in the proper colors. Okay, so there. Top seaplane, you have X and Y, but you cannot access Z. Front seaplane, you have X and Z, but you cannot access Y coordinates. Right seaplane, you have Y and Z coordinates available, but you can't access X coordinates. So only two coordinate systems, because it's a flat grid, are available in any seaplane. Okay, so that means at any point in time in Rhino, you have to be aware of what seaplane you're on, because that is where your mouse is working. That's where you're working, whether you want to be working there or not. That's where you're working. So top seaplane active, I'm working in X and Y coordinates. Front C-plane active. I'm working in X and Z coordinates. Right C-plane active. I am working in Y and Z coordinates. And it's going to get confusing if I stay on the top C-plane here. So right C-plane, I'm working in Y and Z. Okay? So that looks like a three-dimensional curve, and it is. But each portion of the curve was drawn on a 2D plane. I used the top C-plane when I wanted to draw flat here. I used the front C-plane when I wanted to draw flat in this direction. I used the right C-plane when I wanted to draw flat in the other direction. Okay? So, if you're not going to use any constraints, anything that will make Rhino behave out of the ordinary, you're always drawing in 2D. You're always scaling, and your pick points and everything are always on a 2D plane. And since that's always the case, and you have no way to escape that shy of a constraint, you have to be aware of what C-plane is active at all times. In Rhino, you need to always know what C-plane is active. Now, constraints that'll get you off of the C-plane: object snaps. Top C-plane is currently active, but if I use a mid-snap, I can grab onto the midsection of that line, which is not on the C-plane. However, the very next place I pick, no matter where it is, it's going to be back on that C-plane. Okay? So if I don't have an object snap lifting me away from the C-plane, I am stuck on the C-plane. Okay, in this case I'm going to reach out and grab the end of it. Doesn't matter where I click next. See, that feels like it's out in three-dimensional space. But it isn't. Once I leave the object snap, all of my pick points are thrown right back onto that front C-plane. Okay? So that's one way to get off of a C-plane, is to use an object snap. Okay? After the object snap is no longer functioning, you're back on that C-plane that you cannot escape from.